Hey guys, welcome back to this video where I'm going through the challenges in my book, The C# Player's Guide. And this time we're going to go through this old robot challenge. I'm jumping around a little bit. It's been a couple months since I've done one of these videos, but I just had a specific request for this one because somebody was stuck on it. So I'm jumping ahead a little bit to here. But yeah, so let's just kind of dive into this. The idea is there's this robot class and we're supposed to just use this code and then build from it. We're supposed to build a RobotCommand class and some of the infrastructure to actually make this work. But the idea is that there's this robot, we can feed it different commands, and then we can have it go do stuff. In particular, the only things there really is the ability to power on and power off, and the ability to move one unit in each direction. And we've got the X, Y, and powered stuff here. So we've got some sample output here, and that's about it. So I'm going to move this off of the screen. I can still see it. You guys should have it in your book, and then we will. Well, all right, I'll open it. I thought I had this open already, but apparently not. I'm just going to make a new console application for this. And then the first thing I'm going to do is just paste that code into here. And before we get too far, let's talk about what we've got. So this class, this robot class, it has three properties. It's got X, Y, and is powered. These are all settable from the outside. There's no special logic that is needed here. So they're all just plain old auto properties. Nothing too fancy. And then there's this list of commands that like so we haven't defined this class yet. That's the thing we're going to be doing. We're actually not even going to define one. We're going to define a bunch of them. But we'll define a command. And this is the list of commands that this guy has. And then there's this run method that looks at the commands. It just iterates through all the commands and runs them all one at a time, and then displays the robot's current state. I had somebody ask me about this right here. It's covered in the book, and it's covered in. Well, let me bring the PDF back for a second. It's covered in the book, but it's one of those things that people miss a lot because there's a lot going on. When you're learning about classes, there's a lot going on here. So I'm going to come here. It's this name hiding in the this keyword. All this keyword is it's a reference to the object that you're inside of. So in this case, where it's just a reference to the robot object that this code is running inside of. It's not anything too fancy. For example, I could come in here and I could say this dot. I can see my own is powered property, or this dot X, or this dot Y, or whatever it is. And so the thing about it is most of the time you don't need to do that. For example, X in this case is the exact same thing. It's already I'm already inside of this class. It already knows this is what I'm referring to when I do X. So if I do something like console.write line X, then it already knows that I'm referring to this, and you see that down here as well. But there are cases where having that reference to the current object makes sense. And for example, console.writeLine can do. You can give it literally anything. There's a bunch of overloads to this, and for example, there's an overload that is a string, and that's actually what's happening down here. We're calling the version of WriteLine that is a string, or we could do WriteLine 1, in which case we're calling the version that popped up for a second. Let me do this again. It's calling the version that has an int parameter. When I pass in this, it actually is calling the version that is this one right here, an object, a potentially null object. is what it's doing. And console.writeLine, when it's called with just any old object, it will call the object's toString method. In like the default implementation of toString is like the class name. So it's the fully qualified name. So in this case, and that's a whole other topic. So like if there's a namespace, if it's in a namespace, then it'll include the namespace. We haven't, where we're at in the book right now, we haven't talked about namespaces. So it would basically be the class name. So we haven't put it in a namespace because we haven't discussed that yet. But that's the idea here, is like now I can take myself and hand me off to console.writeLine is really what we're doing here. Now, if I come back to this command, so the commands themselves need a reference to the robot that they're operating on. And what we're saying here, this run method it requires a robot reference in order to do something. So we're just saying, I'm gonna call this command, and since it needs a robot, I am a robot. I'm gonna hand myself off to this. So that's what this is. So that's the type of thing that this comes up in. There are other places where it comes up. If we go back to the book here, this like the place that this is coming up is another good example. That if your name, like if your parameters or your local variables are named the same thing, which you should generally try to avoid, and like usually a public field like this is capitalized. It'd be capital name. It's upper camel case or Pascal case. So normally, like these are misnamed. These don't follow the convention. So normally this should be a capital N. And even if it's a private field, which this comes from the before times where we weren't dealing with information hiding. So this is in the before times, and we just had a public field. Usually when you have a private field, what people do is they'll just put an underscore on it, and then you wouldn't do this dot name. And I think it describes that right here. Like this is the more normal thing to do. Is if you have a private field. If you have a public field, you'd usually do capitalized. So that's what that code does. It's you shouldn't have to modify that at all for what we're talking about here. Let me see if I can find the challenge. Here we go. We're back. All right. So now I got that for a reference. And let's just walk through the steps here of what this is doing. So create a robot command class with a public and abstract void run robot method. All right. So I could put this like in terms of order. My main method's going to go right here at the top. But after that, I can put these other classes in any order I want. So, public class robot command. And it needs a public and abstract void run method. So public abstract void run robot. Now, I even as I'm doing this, I can already see a slight mistake in the book. It doesn't compile right now. It says the code above will compile, and the reason why, like if you look at this error, that method RobotCommand.run robot, so that's referring to this one, is abstract, but it's contained in a non-abstract type robot command. In order to have an abstract method, the type itself needs to be abstract, and the reason why is like this code does not have, like, this class is not complete. This is like a placeholder. It's expecting that it's going to be defined, and all robot commands will have it for sure, but this isn't defined anywhere because it's abstract. So we need to say, we need to add this in here, abstract class. So now we have an abstract class. We're okay to make an abstract method. So the book doesn't necessarily call that out as clearly as I feel like it probably should have. That's my mistake. I often find doing these challenges live, on video, I spot a lot more mistakes than I realize, than I caught when I was doing the solutions online. Which, by the way, I'm not expecting this code to come out exactly equal to the solutions online. I've probably said that in other videos like this. I'm not taking my solution online. So you may get two slightly different versions that you can compare. They should be more or less the same, especially on some of the smaller challenges like this. The boss battles, I know my videos for the boss battles have ended up fairly different in some ways than what I had as the solution online. So Anyway, so I think we've got a complete class, and it does compile, at least in the sense that, like, I actually think if I told this to compile, I think it would say you don't have any main. Like if I tell us to run, it's gonna not know what to do. Yeah, so there's no main method. I could fix that really easily with just the console.write. There, now it has it. And now it should run. I'll just say hello world. Weirdly, it hasn't. I don't know what it's doing. Do over. Having weird things happen is a normal part of making software. The trick is you got to figure out why without panicking or getting frustrated, which that part's not easy. So I just reran this, and now it displayed. I don't have an explanation for it. But I think at this point, if I ran this again and again, it would still work. So something weird happened, and now it's fixed. So I'm going to not worry too much about that. All right. So I got the robot command, but now I need, so make an on command, off command class to inherit from robot command and turn the robot on or off by overriding the run method. So now we're going to make a bunch of different flavors of robot command. So public class, and these are not abstract. And then, so that means, public class. These are supposed to, they inherit from robot command. So I need to add this in. And now at this point, you'll see that it'll say, you're supposed to, robot commands need to have this run method, and you don't have it yet. On command does not implement inherited abstract member. It's a mouthful, but it's inherited because it was in the robot command class that we're derived from. And it was abstract, which is why we need to do it here. So it does not implement that method. So one cool thing here is you can click on this and say implement abstract class, and poof, now it makes an implementation. It doesn't work. It has this exception thing in here, which it won't work, but it does give you, it fills out all of this for you, which is nice. So I'm going to delete the exception that it was putting in there by default. And I'm going to say, okay, so the on command is supposed to make sure that the robot is powered on after we get done with this. And that's pretty easy. We've got a reference right here to the robot. And all we have to do is type robot dot command, not commands, robot dot, there's just powered is true. So when this command runs, we should set it, the powered state to true. And that's all we really need. And at this point now, it maybe starts to make a little more sense with what's going on here. This command, every command needs the robot, a reference to the robot that they're running for, because they're supposed to be able to manipulate the state of the robot. And there's a lot of ways that one object can learn about another. And again, I'll come back to the book here and point this out a little bit more. It's in this object-oriented design thing. A lot of people read this and they don't. I don't know. There's something about the way I've written it that doesn't capture the essence of it well enough, or I don't know. Maybe it's at the very end of a long chapter with a lot of content, and people are maybe mentally drained or something like that. And but yeah, this how to collaborate. This is talking about how do objects come to know about each other, and there's a lot of ways you can do it. The most direct one is just creating a new whatever. Sorry, I had to stop for a second there because I kept getting a bunch of messages in Microsoft Teams, and I wanted to turn that off while I'm recording this. So we're back. Yeah, so there, like, you could just create a new object. That's a fairly straightforward way to do it. If you create the object, then you're going to have it. The catch here is like that works in some cases, but like here, the command can't just create a new robot and use it. We need the robot, not just any old robot. We don't just need to make a new one. We need a specific robot. So given that we need a specific one, there's a lot of options here for like how do we get them to know about each other. Well, one thing we could do is, for example, we could have we could have one of them create the first object, and then when we create the second one, we just supply a reference to the first object in as a constructor parameter. And like this code here does that with the game is just handed all the asteroids. We could have done that here. We could have said like public on command, and then we pass in robot. And then we would probably just save this off to some, like in this case, it could probably just be a private, it could even be read-only, a private read-only robot. So now we have this like semi-permanent, well, actually in this case, it's very permanent reference to, like it can't be changed. In this case, it can't be changed to a different reference because it's read-only. And so we'll have a reference to this robot forever. So this is this is kind of the long-term approach, the long-term way for two objects to know about each other. And by the way, when I say that, like the robot does not know anything about the command. Just from this, it actually does later, because like that right there, these commands, it will know about the commands eventually. So this is one way to do it, and it's a pretty powerful way to do it, especially for things that are like long-lived. Like if the and I think the asteroids in the game thing over here is a good example of that, where like the game probably needs to know keep track of these asteroids forever. So it makes sense for it to like hang on to these references certainly for a while. So that's a popular way to do it, especially for long-lived like associations. For like ephemeral, short-lived things, if it just needs something for just a little while, this method parameter thing is a good choice, which is actually how this code has been set up. So like we can just pass. I'm gonna delete all this. I don't need it. But like, given that we only need the robot briefly while we run, while we run this code, we can just pass it in as a method parameter, which is exactly what we've done here. That's how we've set this up. Is we're gonna give the command and the instance, the robot instance, right when it's time to actually run the code. So it will be given a specific robot and it can run it. In theory, it means that like, since the commands are, in this case, they aren't like directly attached to a specific robot, we could actually make this 6 different commands for this challenge, like 6 instances, and just reuse them, and we could reuse them across 1,000 different robots if we wanted to, because they don't really care. They're not like directly associated with a single robot instance. We don't need to do it that way, and we won't do it that way. We'll create if somebody wants to have, turn the robot on, turn the robot on, turn the robot on as their commands. We'll just create extra instances of on command. We'll just keep it simple. It's easier code that way. But yeah, there are a couple other options in here that, since we're talking about it, maybe we can go through it. But like, another possibility is, I did not mean to do that, asking another object. Sometimes something else knows about it, and we just like we know about object A. Object A knows about object B. And so we just say, hey, object A, can you share a reference to object B? And we just get that, and then we use it. And you see that here. Like this code, which is in this asteroid drifting system, potentially, it has a reference to the game, and but it needs the asteroid. So it just says, game, can you give me all the asteroids? And so it just shares it. This is like a referral from a friend kind of approach. You could also supply it by like a property. So we could have instead of this, we could have said, I'm going to have a property here that's like public robot. And if we make it settable from the outside, there's no specific logic that we need here. Now we would be able to do this kind of thing. that won't work because of how we've set up everything else. But just imagine for a second, like we could do it this way, and now we don't, like, yeah. This is kind of middle ground between the constructor parameter version and the method parameter version, because this is changeable over time. If we ever want to attach these commands to a different robot, in this case, we could do that, but they are attached. So this is like a short term, but like kind of like not as short term as just the method parameter that's just like transactional. It's like I need it right now, and as soon as I'm done with this little operation, I'm there's nothing else I need with it. I don't need to hang on to it forever. So this is kind of that middle ground. The last thing that the book talks about there about how things can find out about each other is with like a static reference. And if, for example, we did something like this, where we said public static robot, the robot. So now we have this property and it's static, so it's accessible just through the class name, and it has an instance of the robot. Now we could access this through the class name, robot.the-robot. Oops. Anyway, something like that. And so now we can like hunt down the robot from anywhere in the whole code. This is not like, this should usually be your last resort. It works, but the problem is now this is actually more or less what is called the singleton pattern, and this should be your last resort. It has its uses, but unless it's like by its nature, there can only be one robot. That's the time where it makes sense to use something of this nature. Because this design choice prevents me from running two robots at the same time, for having two robot instances, because this code can't manage. That has no capacity to differentiate the first robot from the second from the 100th, right? So there's no, this particular design, in this case, this particular design choice prevents us from having multiple robots. So if it's by its nature, there can't be more than one. A singleton could make sense. But we're not doing that now. The book has already, like the code in the book has already told us how it wants us to handle it. So we don't have to like figure that out in this case, other than it's still interesting to do. But anyway, once you got the pattern here of how that works, the rest of these will go fast. So let me, let's see. I need to jump back to the old robot stuff here. I don't know that I needed to show you this, but so we've done the on command, we'll do the off command, and then we'll get the north, south, east, west ones, and then we'll go from there. So we have this on command. This is taking up a lot of vertical space. This is a personal choice. Like different people prefer it different ways. Given how small that is, I think I'm gonna just do it that way, because I'm gonna have a bunch of these. They're all very short. And I'm just going to keep it short rather than just having a lot of vertical space with all those curly braces. But not everybody else would do it that way. In fact, like if this class just had a little bit more meat to it, if it wasn't, this is the only real logic here. Like this is actually kind of a lot of overhead for something very small. So I'm trying to keep the code smaller because there's just not that much here. But anyway, again, like I said, personal choice. If you prefer all the curly braces, I think that's fine too. Actually, I wonder, now that I'm thinking of it, it would surprise me if I can just actually get away with a expression body. Yep. So now I'm not even squishing all the curly braces onto one line. I'm gonna run with that actually, now that we've got that up. But it, like, again, not everybody likes expression bodies. I love them. I think they make it really simple. I use them whenever my code supports that, whenever I've got just a simple expression. But again, not everybody likes it. So, okay. So that's the on command, the out command. I think they're both done. And now we need the move north command. North command, south command, east command, west command. So I'll just make one first. So north command. And in this case, it's not going to set power. It's going to set, let's see, north would be, we had to, let's see, I guess this says north, let's see, they move the robot 1 unit in the plus Y direction. So that would be, so Y we could do that. So this will just increment y. And then we need the south command. That's the opposite direction. So y minus minus. And now we need east and west. And let's see. West command moves us in the negative x direction. So we'll do x minus minus and x plus plus. And now we have all these commands. And what's interesting about this is, like, I'm going to come up here, and so this, we're actually mostly done. The one thing is that the main method is supposed to ask the user for commands. I'm going to skip that just for a moment. And that's a very, like, in all these challenges, if you've seen enough of these videos, you've seen that that's an approach I've taken a lot. A lot of times the user input part adds a fair bit of extra complexity because you got to deal with people and all the ways they could type in stupid data. And if we skip the human briefly, we can get a feel for how this works, and it's just by using code. And then we can deal with bringing the human in on the fun later. So I'm going to, in my main method here, I'm going to say new. We're going to do this robot equals new robot. So we're going to create a new robot, and let's see, what state do they start in? They start, it's not set to anything. The default for a bool and in int is, do you know? The default for an int is 0, and the default for a bool is false. So that's what these all starts as, is 0, 0. So it starts at the origin, and it starts powered off, which is a pretty reasonable default. I mean, you unpackage your robot from the packaging, and it makes sense for it to be at the origin, whatever that is, and turned off, and you got to turn it on and then move it. So we know now that it's going to start off, and it's going to start at 0, 0. So if we do robot.commands at index 0 equals new power on commands. Sorry, I've already forgotten what I called these. And then robot.commands1 equals new north command. And then robot.commands at index 2 is new off command. All right, so now we've just stuffed some commands in there. And so this is, like, if you look at this, there's room for exactly 3. No more, no less. And that's, like, arrays are a somewhat limited tool. The fact that they can't easily just be resized is limiting. However, this is, like, behind the scenes, even the more complex things that we're getting to soon, they use arrays behind the scenes. Like, this is, like, everything's an array. Any of these collection types are either an array, or there's another type of way you can make a collection called the linked list, where each item, like, refers to the next one in the list. So we're using an array for now. It is a little bit limiting in that we know there's exactly 3 things. But once you learn about the list type in a few chapters, it's a generic thing. That's why we haven't covered it yet. But after you learn about the list type, you could come back and replace this. And then it's like the list type is like an array only, and it uses arrays behind the scenes. Only when you add, like, you could just add an item and add an item and add an item, and you could add 2 items, or you could add 2,000 items, and it will just automatically, like, create new arrays when necessary for it. So, but right now we're just limited to 3, and that's okay for right now. We don't need anything else. And so that's all we've got here. And now that we populated the commands, we can just say robot.run. Oops. And now we tell it to run. Of course, there's no human in the loop here, so it just ran. But you can see, like, I started at 0, 0, and I was this is okay. So we don't see this. We don't see the before version. This is after running the first one. So after turning it on, this is after moving north, and this is after turning it off. So you can see how that's working. And I could do, like, I could come down here and I could say, let's give ourselves a little more room. So we've got 5 commands, and then 2, 3, 4. So we could do move north, couple times, and we can move west once, and then we can turn it off. We run that again. And now, like, we started at 0, 0, the power gets turned on, and then we do move north, so we've moved 2, and then we move west so that we get the -1, and then we turn it off. So like you can see like this progression. We can just put these commands in. We can make this do whatever we want it to do by just stringing together the right collection of commands. And if we wanted to add more functionality in here, like shoot the laser, we could do that too, whether the laser is powered on. So I'm going to delete these and get us back down to the 3 that the challenge actually expects. And then the last thing that is needed here is all we need is to have the user be able to choose these. And so all we'll do is we'll say for int index equals 0, index is less than robot.commands.length index plus less. Now we know right now that this will always be 3. However, by using the length, however long this array is right now, by using that in here, if I do decide to change it to 5 later, I don't have to revisit this code. Like if I had just done 3, and then I came down here and said, you know what, I think I want there to be 5 again, then I would also have to change it right here. So instead of just using a hard-coded 3, if we use length, it just makes that easier to change later, which is a good thing. So now at this point, I just like I could do robot.commands at index 0 equals new north command. Not at index 0, at index. Now the problem here is that if the robot is the robot's going to start off. Oh, I think I failed to do that. So they have these other. Okay, actually this. Okay, I have a bug, but that bug is actually to my benefit right this second. So right now, it's the robot's powered off. It should not be moving, but I forgot to handle that. But you can see now, because I just said this loop is just add in a north command. So move north, move north, move north. It just moves north. But that's a good reminder that I need to come in here and I need to say. So I maybe can't use. I'm not going to be able to keep using an expression body here, and that's okay. So I do this and I say, oops, I say if robot is powered. Well, so I could do it this way. I could just say if robot is powered, then do this. Like that's what I need. I could also do it all on one line. Again, I've seen some people just really, really hate this type of approach, especially if there's anything significant here, which in this case there kind of is. So different people have different preferences. All right, so now with that, I'm going to do this. So I'm adding in this is powered check for each of these. Now with that in there, with that check for making sure that it's powered on, now it doesn't move at all because it's powered off, and that's what it should do. So I forgot to do that before. Now we've got it in there. And let's see. Yeah, so the only thing we need here is to get the user to type in commands to like pick these based on user input. And so what we can do here is we can just say robot command and equals. We'll do console.readline. I'm not gonna make this too fancy. Like if you look at the sample program in here, all I'm doing is I don't even like prompt the user for anything. You just type in on northwest and that's all. So we could do something a lot fancier, and feel free to do so if you want. But anyway, that's that. So now we're going to switch based on the input. So if the input is on, then we're going to produce a new on command. If it's off, we're going to produce a new off command. If it's north, we're going to produce a new north command. I think that's all of them. I always like having these lined up as long as that's not too crazy. It just makes it easier for me to see that mapping from this thing to this thing. So yeah, now we got this command, and we'll just put in that. Let's talk about user input for a second here. There's a lot of ways this could go wrong. And I know I've talked about this in other videos here. When you are just getting started with this, like right now, we don't have all the tools necessary to really truly like do a good job at handling bad input. We do have probably better knowledge than I've accounted for here. For example, this could return a null, so maybe we should account for null. So it could be null. However, so now if like that just solved that warning. I don't know if you saw that it was underlined. I'll do that. That's what it's complaining about here, as it says. Converting no literal or possible null value, which that's the case we're in here. So it's a possible null value to a non-nullable type, which string, this is saying it's not null. With this, now we're saying it could be null, and I'm okay with that. So now coming down in here, there's the possibility that this could be any text imaginable. It could be any of these here, but it could also be null, for example, or it could be like all caps on, or it could be hamburger, like it could be anything, and we actually haven't accounted for that scenario. And one thing we could do is we could, come in down here and say, if it's anything else, then we're going to produce null. Now, in order to, now this whole expression could be null, and this thing says I better not be null. So now if I do that, now it can handle null. So if there's weird input, then this command will be null. So now let's consider what happens what if this is null? Well, that means a null reference is going to get put into this commands array. And this guy is already handling that. So if while iterating through the collection of commands, we encounter a null, it won't call that. So nothing will happen if we have a null command. So in this case now, we've actually handled the user input pretty well. If they give us garbage, we're going to use a null, and null is correctly handled. It does nothing. It's probably not really what we wanted, and there's a lot of other things we could do. For example, we could loop. We could ask again until, while the command is not null, and just say, look, you haven't given me good data yet. I'm going to keep asking you for more data. But that's not really the purpose of this challenge, so I'm not going to go into that too much. But we could do that. If you're doing something that needed to just work, then I would suggest doing that, because this has room for the user to get something that they probably weren't expecting or hoping for. Let's see. I think that should do it. Let's run this and see. So now it's sitting here waiting for me to type stuff in. I'm going to type on, and then I'm going to type south, and then I'm going to type east. And then when I push enter here, it'll finish off the last command and it'll run it. So now let's see, I typed on, south, and east. So here after running the on command, it's on. And then south moves us down in the Y direction. That looks right. And then east moves us, it changes this one here, moves us one in the X direction. So I think that looks like it's doing what it's supposed to do. And I think that means we're, like, at this point, let me just check here really quick. yeah, I think that'll do it for this challenge. I mean, I don't know how long this video is, but kind of long, 40 minutes right now. So I do want to kind of like summarize here a little bit. Like the purpose of what we're doing here is most of the software in this case doesn't need to care what the specific command is. The robot, like in this case, this robot, it has no clue what these commands are going to be. It just runs them all one after the other. And like that's the benefit that we're getting here. We could put anything in here. In fact, we could add a whole lot of other commands. Like we could have a command that's like a teleport to random location command, or teleport to a specific location command. Like we could, for example, let's throw some of these in here. Why not? We're already 40 minutes in. Why not be an hour in? So we could say, let's do it this way. I'm gonna keep this simple for the moment. We'll make this a teleport home command, and then we'll say public override void run robot. Added it already. Should we be able to, if we're not powered, should this work? I feel like a robot maybe shouldn't be able to teleport if it's not turned on. So if robot.is powered, robot.x equals 0, robot.y equals 0. So we'll say 0, 0 is home. That is where it started. And now we could come up here and we could say, we could add in another command, and like none of this code had to change, which is the nice thing about it. We've just added in more functionality without having to like do anything. Like all the infrastructure code didn't have to change. We didn't have to change the definition of a robot command. We didn't have to change the robot, and yet we've suddenly got more functionality. And that's really the purpose. Let's do. Okay, we gotta turn it on, and then we go north, then home. So we didn't get very far from home. We'd have to add in more commands to get farther from home. But I mean, we could have. So I've got this teleport home command. I could, if I wanted to, like let's push this farther. A generic teleport command, and we could have public. Public int. It doesn't even need to be public. Private int x. Private int y. Public. So we'll make a constructor here, not teleport home. Okay. Yeah. So we initialize these, and I can make these read only at this point. And now down in here, I can say. Can do that. So again, like we've just added in these commands, and we can add in any command that we want really easily. We do have to change if we want the user to be able to choose it. We gotta add our command, and then we got to be able to have the user be able to pick it. This is going to be a little bit complicated, and I'm gonna cheat here. Like in theory, we'd want to make this, if we really wanted to go this route, we would want to, like, I don't know, parse those out, and we could do that. I'm not going to right now, but we could, and then figure out what these are, and then like pass them in here. At that point, we're probably well beyond a switch. We probably need something a little more bigger, more complicated. But now I can say let's do on, and then teleport to 1, 2, which should be, that's an exact match for the pattern that we've got here, so that should work. And then home. And you can see now it powered on, and then it teleported to 1, 2, and then it went home. Like I said, I'm cheating there because like that's I could not say teleport to 1, 3. So anyway, but you could add that. You could add in a lot of different commands here, as many as you want, and it would work. And like I said, that's really the point here of this abstraction thing. Like we talked about abstraction earlier on, that like by having this like public API, this public outer shell, all the public stuff, and then everything else is private, we can change the details on the inside. We can change how it works without it affecting anybody. But here we're kind of taking this idea of abstraction to a whole other level, because we can have, it isn't just about, I could go change the code and recompile it and it doesn't affect the rest of my code. This can be a totally different object. It looks the same and it works the same to the outside. That you interact with them all in the exact same way, but on the inside they do different things, and that allows us this just extreme degree of flexibility. It's really, really kind of a cool feature to be able to have this polymorphism thing, this idea of I can call this method and it's going to do a different thing depending on the object that's actually there, but I don't have to worry about what type of object it is. So it's just a whole lot of power. It's a really useful tool. Some people say that that idea of polymorphism is what makes object-oriented programming powerful, contrasted with the other things. Is it's this ability to I'm going to call this method, and it's going to do something, but it can handle it in totally different ways depending on the needs. So I've created this program here where I can have a robot not just do one thing, but it could do 1,000 different things depending on what I want. So it's a really powerful concept. I hope that comes through in this, that these different commands give me different strategies for performing an action, for the robot to perform an action, and then I can also string them together to create a whole little program for the robot to run, a little series of commands. Oh, there's one other thing I should probably mention here, because I've seen it bite people. The robot has this run method. The robot command, I've gone past it already. It was down here. Wait, where's robot command? There it is. It also has a run method, and they're different methods. The robot's run method is not abstract, and it just runs all of its commands. Each command has its own abstract method, and we don't know what we're going to get. This code doesn't know what's going to happen when we run each of these commands. So they're named the same thing, and that's totally fine, but they're different things on different they're different classes, so they're not the same method at all. And there's a part of me that wishes I had called either this run program or something like that, or maybe call this run command so that they have a different name. But that's where we're at. That's what that book asked for. So like I said, it does work, and I chose those names because that just felt intuitive to me, that you run a command and you run the set of commands, and it doesn't have to be anything fancy. So all right, this is a totally different thing, but I got curious here. If we did this public, I probably shouldn't do this. This is going to be another 30 minutes. Maybe I'll do another video. I'll describe what I was thinking. Maybe somebody can just go do it for me instead of me doing it. But what I was going to say is right here, we're iterating through the commands. One limitation of what we've got is the program will be, in this case, exactly 3 instructions, and then you end. And it would be kind of cool to have the ability to have a command that starts the program over again. Because if you had that ability to change which command is the next command, you could create loops and if statements and things like that for the program to for the robot to work through. And all you need basically is one command in here that allows you to set the the current instruction, or to like offset from where you're at. So if we turn this to it's too much fun to tinker. So I'm going to call it a command pointer. In the programming, like when your program is running, the CPU if you're using x86, x64, ARM, like there are potentially architectures out there that do it differently, but pretty much any program that you're probably running on has this notion of, I can keep track of which instruction I'm on, and it's usually called the instruction pointer, or the IP. In this case, because these are commands, I'm going to call it a command pointer. And if I make this settable, then one thing I could do here is I could just say while, like I can make it so that a command could change this. I just need to rearrange this code, this for each. So instead of a for each, I would need to say like, so I'm going to delete that for a second. Don't try this at home, kids. This is going to get really complicated really fast. So we could do commands at index command pointer. So we can pull out the command from there. And it may be null. So we pull out that current one. And then what we would need to do is say while command pointer is less than commands dot length. So until we reach the end of the program, do this and command pointer plus plus. So I turned it into a while loop instead of a for each loop. This code is like way uglier than it was. In theory, if I didn't introduce any bugs, which what I just did was fairly complicated. If you're not keeping up, like I said, don't try this at home. It's fine. But if I do on north, okay, that seems like it's working, right? All right, so now I have this command pointer, and in theory, what I could do is come up here and I could have I could make a command that is like a repeat command, new repeat. And oh boy, this is going to get super exciting here in a second. Repeat command, and then what I'll do is I'll change my command pointer, my instruction pointer, and I will set it back 2, and that will set it. This is kind of hard to visualize. The first thing in the list, I'm going to do, what I'm going to type in is on north repeat. So the command number 0 is going to power it on, and it'll run that. Actually, you know what? I'll just set a breakpoint in here. We'll walk through this. Actually, before I do, let's just see if it works. Hang on a second. Okay, north, repeat. Okay, it worked. Do over. All right, so I'm going to put a breakpoint in here, and now we'll look at what this is doing. So, on, north, repeat. Okay, so we just got into the run method. Our commands, if you look at this, our commands are on, north, and repeat. So our command pointer, the default value is 0. Command pointer is 0, and our commands.length. So we're going to run this command. We haven't gone past the end of our instructions. And so the first thing we do is we pull the command out, which we got the on command. Yep. And now we'll run that. And so now the robot should be, if we come up here, we're still at 0 and 0, but we are powered, which is what our program, I just ran that console.write lines. That's what we should see. 0, 0, true. And now we move forward, just like a program does. We from one instruction to the next. So we say, okay, we're going to move to the next instruction. And now we loop around again, and now we're at number 1. We were at 0 before. That's still within the bounds of what we've got. So now we pull out this command, and this time it's the north command. We're already powered on, so this should work. And now we run that, and now our y should have changed to 1, and it did. We can see our output again. So far, so good. Now, at this point, we would normally have one more instruction to run. So our command pointer is 2. This, like I said, the next time through this, if nothing else weird happens, this would be the last instruction. However, we pull out the command, and this time that command is a repeat command. And we run that, and what happened? Command pointer is now back to 0. So in this case, like, it didn't change the state. Like our X and Y is still the same. Like you can see that here, X and Y are still the same. We're still powered on. We didn't actually change any state. What did change, and it's not being displayed here, but we could do it, is the command pointer just backed up 2 spots. We jumped back in the list of commands. We jumped backward 2 spots. And now when we increment again, so we were at 0, we're going to increment as we always do. And now our command pointer is 1. And we're going to pull out that north command again. And we're going to run the north command. And now we're going to increment again. So now we're on the repeat command again. And now we're going to run the repeat commands. And we're going to back up 2 spots in the instruction. Back up 2 spots. And then we move forward 1. Yeah, so and now we'll just keep repeating that, honestly, forever. We've made a while loop. And what's interesting about this is, like, all we needed is a single instruction that allows us to, like, change what the next instruction is. Sorry, a single command that allows us to change what the next command is. And now we've got this. So this is, like, I called this repeat because it just backs up. It backs up to the instruction immediately before the repeat. But, like, again, we could make this a whole lot smarter, and we could have this, like, especially if we gave ourselves a little more room here, instead of 3 instructions. If we had, say, 100 instructions, we could use, if we gave ourselves a little more room to maneuver there, and then we made this smarter. So imagine, like, instead of calling this a repeat, let's call it a jump command. And this is not the robot jumping. This is the instruction pointer. Just stop that. This is the instruction pointer. I keep saying instruction pointer, and I wrote a command pointer below. That's because in this robot thing, we call them commands. But I'm kind of mimicking the actual CPU. Excuse me. In fact, literally what we've done here is we made a little virtual machine. We have a robot, and it has its location and its X and Y, and, like, we can do all these different things, and we can just feed it instructions, and it'll do whatever we want it to do by giving it stuff. In a lot of ways, we've made a little, like, it's almost like we're programming an assembly, only we are using these command objects instead. So we've made a little, our own little programming language, and we can just stick whatever commands we want in here. So if I make this teleport command, I make this jump command. Maybe what I'll do is I'll rename this to, like, relative jump command. And then I will have a constructor parameter here, public. I don't need it to be public. Private, int, offset. And then I'll make a public relative jump command int. Yep, that's what I want. Smart enough to figure it out. I can make that read only. And now here what I can do is I can just say plus equals offset. So now I have the flexibility to do whatever I want. And here I can put a -2, but. So now that'll do the same thing as before, but let's give ourselves more room. So now I've got 20 instructions, and I'm going to remove the user input here. And I'm going to do this. I'm going to say robot.commands at index 0 equals new power on command. So we turn it on. So that's our first instruction, robot.commands. So now basically I'm programming this robot in C# code new north command. Robot.commands index 2 is new. Let's make this guy go in a little box. Robot.commands 3 is new south command. Robot.commands 4 equals new west command. So that should go all the way around the little loop. And then robot.commands 5 equals new jump. So again, this is like not the robot jumping, it's the instruction pointer, the command pointer, the which instruction is next. So what we want to do is we do need to offset for this command. So if we only said go back 1, we would repeat this command over and over and over again. We want to go back 1, 2, 3, 4, 5. So if we do that, now we should get the robot going in a little square over and over again. One thing I actually want to do here is not console. Command pointer. We should, when we tell us to run equals, we should always reset that so that if we run it again. So now you can see it's a 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. Did I go back too far? It might be kind of nice to see what command we are actually running at each of these steps. Because like it's a little weird to me that we stay at 0, 0. I might have gone back to the powering on one. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0. I think we might have gone back too far. So let's do this. I'll set a breakpoint in here. Let this run. And the question is relative jump. Okay, so the jump should let's just see what the command is. Command is north. Oh, okay. It makes sense. I was missing the fact that the fact that we stayed here during that instruction, that was the jump command. So the thing that changes is the command pointer, like the instruction pointer. Like, what's the next command? We were changing that in that command. But what's interesting about this is like if you do it right, like we just made a loop, and now we can loop through all of these. Oh man, I didn't mean to push that button. Like if we could like store some state on the robot, we could make an if statement. Like this is that jump command is like a unconditional. It will always jump. If we just had something that was like a conditional jump, if we had something that was like like honestly, all this thing would need here is like, I gotta stop. I'll keep doing this forever. I'll do this all night. So I'm gonna stop myself, but it wouldn't be too hard to keep going with this and do some pretty cool things if we just had like a little bit of like state in here. The equivalent of a register, if we just had like a little memory location in here, like a public int value. So we've got a single little thing. We could have a conditional thing. And if the value is whatever, so we could have other things that do update, depending on stuff. We could have an instruction that says if x is 10. I mean, I guess we could probably even just do that right now. We could have a very specific conditional thing. Anyway, like I said, I'm not going to do it. Got to stop myself. But at any rate, I hope you can imagine just how like there's a lot of things you could do with this, and like most of the code doesn't care which instruction you've got, which command you've got. It's just a command to it, and it just knows that it's just supposed to use it, and that by interacting with it, it'll do what it is supposed to do, and that's all that it cares about. And that abstraction thing gives you a lot of flexibility, because we can swap these commands in and out however we want, even as the program's running. Like at this point now, it actually almost makes sense to have something where I could say, I could have a command that changes one of the other commands. Like I could have a command that says set command, that messes with the other command. So I could have this program that modifies its own commands as it runs if I wanted to. There's so many cool things you could do. A lot of flexibility. This idea of this robot and programming a robot is really not the only way that you can have this concept of abstraction. To wrap this up, instead of going down deeper into this rabbit hole, I will just say that for example, there is there's code that operates. So there's this concept called a stream, and it's just an array of bytes that you can work with as you iterate through them. You don't, when you're using a stream, you don't know where that stream of bytes came from. You don't know if it's from the network or from a file, or it's just a pile of bytes in memory. And when you're working with a stream, you don't have to care about that. You can just add more bytes. You can pull more bytes in, and you don't care if they're being read from a file or from the network or anywhere else. And so that's I think a pretty good example of that idea of abstraction and polymorphism. Is there's a lot of different flavors of streams out there. There's a file stream and a network stream and a memory stream. And you don't have to care how the bytes got there. You can just interact with the bytes however you want, and it just works. And they will update the file, or they'll update the network, or whatever it is. And it's just this really that concept of polymorphism, and being able to just have you call the method and you don't know how it does it, and it could be different at different points in time. Different objects might do it different ways, but the rest of the program doesn't have to care about that. So anyway, I've gone on way too long on this, so I will just stop it here. We really got done solving this challenge a long time ago, and I think the next challenge in the book builds on this. So I'm going to back up a bunch for the next video, but anyway. Okay. Thanks for joining me, and I hope all these diversions were at least somewhat interesting. They're way, way, way beyond what the challenge expects. Just some interesting things to think about, though. And with that, I will see you guys next time.